Hello and welcome to Cloud Insiders, the podcast that brings cloud down to earth, brought to you by Extrovert. Today we are taking a look at application transformation, and we are joined by Elton Stoneman, architect at Docker, Plural-Sight author, Microsoft MVP, and author of Learn Docker in a Month of Lunches. Hello, Elton.
Hello, thank you for having me.
No, thank you very much for coming on. My name is Stuart Robinson and I will be your host for this podcast, but I'm quite boring. So, Elton, can you give us a brief introduction, where you've come from and what makes you the man you are today?
I'll certainly try. I don't promise to be any less boring. So I work for Docker. My job now at the moment is helping people get started with containers and take their old applications and their new applications and run them in this kind of fancy new world that makes everything better. But my background is all in consulting. So I've been a .NET consultant for most of my career. So I was building and architecting big, ugly monolithic systems, and now I teach people how to break those up and deploy them to the cloud or to a more modern data center deployment. What's made me the man I am today? Crikey, I'll have to think hard about the sort of man I am. That's in full. But certainly career-wise, the things that made a big difference to me, being made Microsoft MVP, because that's a great community to be part of, because I really try to do a lot of stuff. I blog a lot, I tweet a lot. I'm trying to, next year my plan is to do a lot of YouTube stuff, little short videos to introduce people to key topics. So I'm keen on all that. And then Plural-Sight, when I started recording for Plural-Sight, that's a great way to reach a lot of people and help them. I get a lot of good feedback from that. So yeah, that's kind of got me to the place I like to be career-wise.
That's absolutely brilliant. I mean, that was a fantastic little breakdown there. Thank you so much. So if we just get rolling straight into it, starting at a very high level, I want to talk to you about applications. Businesses are dependent on creating and running applications to meet increasing demand for services. In fact, the proliferation of applications is such that more applications are being written in the next couple of years than they have done in the entire past, really. With this in mind, anything to speed up the creation of applications, making them more stable and increasing speed for the end user is imperative. And this is where application transformation comes in. In a nutshell, what is application transformation and how is it enabling businesses?
Yeah, it's a great question. I love that statistic about more apps are going to be written in the next couple of years than ever before. So for me, the app transformation part is trying to make those two sets of applications that you've got, because those apps that you wrote 10 years ago, you're probably still using those. The apps that you're going to write next year are going to be small, easily deployable to different platforms, easy to scale up and down, easy to update, all that sort of stuff, because you're going to use modern approaches and modern architectures and modern technologies. But then you've also got this old stuff that you still run because your business depends on a lot of that. And what I like about this transformation piece is you can take those old apps and with a fairly minimal amount of work, you can wrap them up so they work like new apps. And then you can deploy everything to the same place and you can manage it all in the same way. So if your end game is to run a whole bunch of stuff on a managed Kubernetes service in the cloud, all the managed services now have Windows support. So if you've got a legacy Windows estate that's currently running on Windows Server 2008 in some data center somewhere, but all your new stuff is going to be on Kubernetes in the cloud, actually you can take your old stuff and you can run that in your Kubernetes cluster as well. So for me, that transformation piece is two parts. There's the getting the pipeline in place, which is the kind of core delivery pipeline for your new modern architectures, but also making sure that pipeline fits for your old stuff too. So that's where the real power of this comes in, I think, is that you have consistency across your whole stack for the tools, the artifacts for how you package these things. And then if you want to do more, like a wider transformation and bring your organization into that too, and break up the silos and go into a more DevOpsy thing, that's so much easier if everyone's using the same tools and talking the same languages. So that's how I see that transformation stuff.
And so containerization and everything like that, that very much comes under the cloud native silo of thinking, doesn't it?
It does, yeah. And the cloud native term, which I never used to like originally, but I've come around to it because that's what everyone uses now. It's just a better way of saying modern, because modern doesn't really mean anything either. The Cloud Native Computing Foundation used to have this definition on their website, which they've since changed. But it used to be things like it's container driven, it's dynamically managed. It was the core kind of tenets of what this architecture looks like. But actually, if you flip it around, what you're really thinking about is what business benefits you're looking to get. And the agility is the thing that people really focus on, the ability to say, we want to make a small change to our application. Well, if you come from an enterprisey background like I do, there's no such thing. Like one line of code still takes you 3 months to deploy because you've got to wait for the next deployment window. And actually smaller changes tend to take even longer because you only deploy 4 times a year, you want to make sure you get big new features in that deployment. So I've had small features that get pushed back for, month after month after month. And the ability to say, look, you want your small feature? We can package that up because we have a small service that powers that feature. We can make a small change. We've got an automated pipeline that will run a whole bunch of automated tests. It'll deploy it to our representative cluster somewhere, and we can test it out. And when we're happy with it, we just push a button and it goes to production. And you can release as soon as the feature is ready, rather than waiting for these big accumulation of features. So the speed and the agility is really important there.
Yeah, keyword being agility there.
Yeah.
I think absolutely essential to today's business, really.
Yes.
So, Evden, you've spoken a lot about containers, and that as a technology just keeps getting better and better and better, going strength to strength. And as, of course, births such giants as Docker and Kubernetes, its popularity has even started to edge towards dethroning VMs and traditional virtualization in the coming years. I won't ask for a full-scale deep dive because we've done a tech focus before, and I'll post those in the show notes. But can you give us a rundown of what containers are, container platforms, and how they compare and how they maybe dethrone VMs?
Yeah, sure. So the idea of a container is it's a virtualization, but it's virtualization of your application. So if you can imagine, if I've got an app that I want to deploy on a virtual machine, what I've actually got is I've got my server. On top of that server, I've got some sort of operating system. On top of that, I've got a hypervisor, which is going to power my VM. Then I've got my VM, which has its own operating system, and then I've got my application. If you were to draw that out, you've got like effectively a pyramid of the size and complexity of the software. And right at the top, the thing you care about is the tiny thing, which is your application. And you have all this other stuff that you have to manage in some way. Like even if you're using an IaaS service in the cloud, you're still managing the VM operating systems, you're still managing uptime, all that sort of stuff. What Docker does is it lets you take your application and run it in this thing called a container, which is just a really lightweight boundary around your app. So your app process is running directly on the server, but it's isolated from all the other containers. So inside that container, my app has got its own space. It's got its own allocation of memory and CPU. It's got its own access to the disk. It's got an IP address and a host name and all that sort of stuff. It thinks it's its own dedicated machine, but actually it's using all the resources of the host machine. And the great thing about this is it works across different platforms in the same way. So I can containerize my Linux application, and maybe I'm running that, on a cluster in the cloud, or maybe I'm running it on my Raspberry Pi because I'm just testing something at home. It's the same container technology, it's the same tools that you use, and same for Windows as well. So I can take my .NET application that's 10 years old, I can wrap that up to run in a container, and then I can run that in the data center or on the cloud. The clustering thing is all about how you take those containers and run them at scale, which is where Kubernetes comes in. So what Kubernetes is effectively is a bunch of machines that can all run containers, but instead of talking to each machine individually and saying, please run this container and please run this container, what you do is you describe all the components of your application in this file that we call an application manifest. So you describe all the pieces of your application, you throw that file to the cluster, and it decides where to run containers. So it knows about all the servers, it knows which one's got spare capacity, which one's running hot. So it schedules all the containers to run, and then it monitors them. So if a server goes down and takes a bunch of containers with it, it starts replacement containers on other servers. If your apps start behaving badly and they start ramping up on memory usage, it kills them and starts them again. So it gives you that kind of management piece, which you can really get to the point where deployments are super fast because everything spins up really quickly in these containers, and also your apps are kind of self-healing. So you can structure your deployment such that most of the known failure paths for your application can be dealt with by the orchestrator, either by restarting a container or scheduling a container somewhere else on a different machine. So you only have to do intervention, human intervention, if things go kind of badly wrong. And that's really appealing for a lot of people who are managing large estates of apps.
So really, we're talking about Skynet then, are we?
Yeah, pretty much.
Self-healing, just going to slowly take over. I get where you're coming from. So Docker is absolutely huge in this space and has definitely been the Mac Daddy for a while now. What are its common use cases? Kind of what's made it the thing that it is?
The thing that Docker is so good at is the developer experience, the making things easy to wrap up your application in a container. And it's done that so well, and it continues to do that really, really well. And if you're using containers, you're going to start with Docker in all likelihood. There are other ways to run containers. There are other technologies. Part of the Docker, the DNA of Docker is for things to be open. So there's an open API for what a container looks like and what a container package should look like. So other people can implement that, and that's really important. So you're not tied into Docker the product, because there are other ways to run containers. But Docker makes things super easy. So I can run Docker on my servers, Windows or Linux or Raspberry Pi. I can run it on my laptop as well. So there's Docker Desktop, which is on Mac or Windows 10. Makes it super easy to take your applications, run them in containers, kind of get up and running with it. And the great thing about that is that it powers all these really interesting scenarios because it makes it so easy to make that first step of taking your app and running it in a container. So I've been doing this for quite a while, and I did a conference session where I was talking about exactly what you've just said. The conference session was called "Why Containers Will Take Over the World," and I kind of walk through a bunch of use cases with that. And the first one is just migrating your apps to the cloud, because if you've got a bunch of apps that are already running and you want to move them to the cloud, you've got some options there. You can either take them to pieces and work out which managed services from your cloud are the best fit, and rework your application, re-architect your application. But that's a project, and that's probably a chunk of work to do that. And when you've done it, your app's going to work on one cloud. And then if you want to go multi-cloud or you want to move across, it's another project to get there. So a lot of companies are moving to containers first. So the migration piece is making this stuff work in Docker and Kubernetes, and then I can deploy it in Azure or AWS or Google Cloud. I'm deploying the same thing everywhere. So this level of standardization across the data center and across all the clouds means your migration piece is not a one-off thing that ties you into a particular platform. It's a piece of work which lets you run your apps anywhere. So that's really appealing. Then there's the next stage of that, which is I've got these old applications that are, the archetypal 10-year-old monolith. I want to move it to the cloud, but actually we're actively working on that application and we are adding features all the time. So once it's in a container, it's really easy to start breaking it apart. So there are established patterns now for how I can break apart the front end of an application or the back end of an application and plug everything together with containers. And that makes it really easy to do things like say, well, there's a certain feature of our app that needs to change all the time. And if we break it out of the monolith, then we don't need to do that 2-week regression test cycle for that feature, because every time we do an update to that feature, we're not going to touch the monolith. The container that's running 90% of our code isn't even going to be touched. It's still going to be running. We're going to update this small thing, which is just this feature. You can do it kind of at a business value level. So rather than re-architect your entire app, which is some of the apps I've worked on, that's a 2-year project.
Yeah.
So rather than do that, you look at the features that would give you value, that would give you the increased agility or improved performance or security or whatever, and you break those pieces out. So that modernization piece is really important. And then there's the new apps that you've talked about, the cloud native stuff. All that cloud native stuff is all container based, for the simple reason that if I want to have a highly distributed architecture where I've got lots of things that are all talking together, those things need to start fast and they need to be able to find each other quickly, and they need to be able to work nicely in a managed environment. And Docker makes it easy for you to do that on your local machine. So I can spin up, a dozen containers on my local machine that all represent small services that are all talking together. And I can even use, Slack at the same time, because the containers are so lightweight on my compute resources. I can spin up my entire stack and be doing other stuff as well. So that's really beneficial from the developer workflow.
Yeah.
I've got two more to go through. Do you want me to carry on?
Yeah, go for it.
Okay, cool. So the last two scenarios, one of them is the technical innovation, because the interesting thing about containers, and I've been using them since 2014, before Docker even went to version 1.
Wow.
The really interesting thing is that it's become ubiquitous for all sorts of things that you hadn't really thought about in the past. So things like, IoT. So typically when people are shipping an IoT project, one of the hard things is getting software down onto the device and updating it in a reliable way. So they tend to do a whole firmware update where they download the entire firmware, the device recycles and reboots and loads the new firmware. If you happen to unplug it at that point, it's bricked and all that sort of stuff.
Yeah.
Companies now are moving towards, well, let's use containers for that. So we don't need to reboot the machine. We're going to publish our application updates in containers. We'll get and Docker's got that kind of distribution stuff built into it. So I can pull the new container package down, replace the running container. It's much safer, it's much quicker, it's much faster. So from things like that, all the way up to CI/CD pipelines. So GitHub have just released their new GitHub Actions, which effectively lets you build a whole pipeline in GitHub using really small components, just do all the pieces that you want to do. And all those components are Docker containers.
Yeah.
So, everything from what people are doing in production to the tooling to interesting new things like serverless. Serverless is all containers. So, and the last one, the last one is that digital transformation that I kind of touched on. This idea that companies want to move more to, whether they're moving to DevOps, which works for a lot of smaller companies, or whether they're moving to a more Google SRE model, which tends to work better in bigger companies. Either way, if you can standardize your tool set, standardize the types of things that your traditional dev people and your traditional ops people are working on, it just makes that whole thing much easier. So yeah, those are the 5 things.
Perfect. And just for everyone else out there, because of course I know, SRE, what would be the breakdown for that?
Oh, sorry. Sorry. You just assume that everyone knows all the acronyms. SRE, Site Reliability Engineering. So it's the way that Google run their production systems. So rather than have a DevOps team where one team own the entire product and that team is built up of people who work on the code and people who are traditionally more opsy and they own it end to end, they have a dedicated production support team who they call the SREs, the Site Reliability Engineers. So they're a separate team from the people who build the product. They run the product, but part of what they do is automation. So a key part of that role is engineering to make deployments work easily, to make updates super fast, to monitor everything. So it's kind of DevOpsy, but with a split between the physical project team and the run team, which a lot of companies are more comfortable with.
Yeah. So, and basically at every level, it's engineered for speed.
Yes.
So you've spoken about Kubernetes, but when it comes to container orchestration, what does Docker Compose do, and how does it compare to Kubernetes?
Well, so Docker Compose is not really an orchestrator. What Docker Compose does is it lets you run a distributed application where you've got lots of containers that all talk to each other, but it lets you run them on a single machine. So that's what you're going to do in your dev environment, maybe in your CI/CD environment to spin up your entire app and run a bunch of automated tests. The Docker Compose format, which is an application manifest format, kind of like I mentioned earlier, you describe all the pieces of your application. You can use that to deploy to Kubernetes. I mean, the typical learning journey that people do is that they get down with Docker and then Docker Compose, and then they start to learn Kubernetes. And it's quite a big leap to go from understanding Docker well to understanding Kubernetes well, partly because Kubernetes is so tweakable. You know, there's an awful lot of functionality in there, and in order to make the best use of it, you have to understand there's a lot of moving parts. You have to understand where they fit together, and you have to map that onto your application design and how this stuff all works together. So Docker Compose is a nice stepping stone. So there's an open source project from Docker that you can deploy on your Kubernetes cluster, and it lets you use your Docker Compose file description to deploy your app rather than your Kubernetes description. And the reason why that's important is because Docker Compose is so much more concise. So your Kubernetes manifest can literally be 10 times the size of your Compose manifest, which when you're just learning and you don't need all the extra features that Kubernetes gives you, that can really accelerate your delivery. So you say, here's our Docker Compose stuff that we use locally, that we use in our test environment, and actually we can deploy that to Kubernetes. And as we get more confident and we want to leverage more features of Kubernetes, we're not going to use Compose in production. We're going to use our Kubernetes manifest, but it's a nice kind of stepping stone. So yeah, Docker Compose is not really an orchestrator. It's just for running things on a single machine, but it's also the application definition format, and it's very easy to use, and it can be used with Kubernetes.
Wow, that's absolutely brilliant. So evidently you've got this massive teaching role in your everyday life now. How does one go about learning Docker and containerization, application transformation as a whole, really?
Yeah. Okay. So great question. I've been asked that a few times over the last few years. So actually, the great thing about Docker is it's pretty easy to learn. There are only a few things that you need to master. The core of Docker is this thing called a Docker file, which is just basically a list of steps to how to package up your application so it runs in a container. So the first thing in learning Docker is, if you want to take your existing application and run that in a container and see how it looks, you take your existing deployment scripts or your Word document and you convert that into this Docker file format, which is a pretty easy format to get started with. And all it does is things like, I need these dependencies that I need to download from here, and then I'm going to install, a zip file that's got my application in it, and then unzip the file. And it's a fairly simple thing. So you can containerize one part of your application stack pretty easily. If you don't want to use one of your own apps, you can just get an app from Docker Hub. Docker Hub is where you share packaged applications. There are millions of applications up there that are being downloaded billions of times every week. So you can pull something like a great open source project like Elasticsearch or RabbitMQ, or something that you just want to try out, like Ghost, the blogging engine. All that stuff publishes up to Docker Hub. You can just try one of their containers if you don't want to write your own. the thing you can do first is get used to working with the Docker commands, like running containers, packaging your own app in images. When you execute that Docker file, you get this thing called an image, and that's what you share to Docker Hub. And when you're comfortable with those three things, the Docker file, the container image, and the container itself, that's when you kind of migrate to Docker Compose, because any application worth containerizing is going to have more than one component. So you're going to have a Docker file for each component, and that will produce a Docker image. And then you have your compose file that describes how all those bits fit together. And then you run Docker compose, and it will start containers for each of your pieces. It will connect them together in a private Docker network, so they can all see each other. You don't need to change application code or anything like that. Your app it's completely transparent to your app that it's running in a container. And then when you're happy with compose, then it depends where your journey is going next. Like if you want to go to the public cloud and you want to use Kubernetes, then you can take that compose file, deploy that to Kubernetes, see if that works for you. If not, you have to accept the fact there's a bit of a bump in your learning journey, because Kubernetes is a more complicated product. But then you're going to make the next step and learn Kubernetes. If you're looking at on-premise, it's kind of the same thing. You can either choose to use Kubernetes, in which case heavily recommend that you pay someone to manage your Kubernetes cluster for you, because it's all open source and you can do it all yourself. But if you do, you're going to need a full-time team to manage your cluster, and the cost of that team, who probably don't want to be spending their time managing clusters, would be better going to someone like Rancher or Docker Enterprise, who can manage that stuff for you on-prem. So you're going to have Kubernetes clusters. The alternative orchestrator, which people are use less frequently, but it's almost as powerful as Kubernetes, but it's much easier to get started with. It's called Docker Swarm. And some people like Swarm because it uses the Docker Compose format, but it has most of the features of Kubernetes. So you have a couple of choices, but the kind of core learning path is Docker Compose, and then Kubernetes, if that's where you're ultimately heading.
I mean, you basically just turn that into 3 steps of learning, which is absolutely fantastic.
And those 3 steps, they're not equal. So learning Docker for your own kind of application, I would expect from zero to be able to run your own containers with your own app, you're probably going to do that in a week. And then that's not going to be production ready, but it's probably only going to take another couple of weeks to get the production readiness stuff that you need. Compose, again, a week or 2 to get that stuff up and running. And then Kubernetes, reality, a few months to get confident with doing stuff in Kubernetes.
Brilliant. And so these are the steps, but where would people go to get the materials to kind of learn those individual steps? Evgeny, in your opening gambit, we described you as a Plural-Sight author, and you have a book coming out.
Yeah, absolutely. So I'm working on that at the moment. So it's with Manning, and Manning have this great early access program. So you can go and buy the book now, and you can read the first half of it, which has been kind of been through the review process and all that sort of stuff. And you can read that and feedback, which would be really great. And then the rest of it will be done by the end of the year. And then the physical book comes out, I think, spring of 2020. So it's called Learn Docker in a Month of Lunches. And that month of lunches format, the idea is there's about 20 chapters. The chapters should take you about an hour to read and do the exercises. It's very hands-on, so you get lots of experience with all this stuff. That's suited really well to Docker and in fact to Kubernetes. There's not much Kubernetes in this book, but maybe there'll be a Learn Kubernetes in a Month of Lunches one day.
Oh, spoilers.
But the Docker book Docker breaks down into really nice little components. So each of those chapters is something you can work through, as simple as how do I run a container, to how do I package my own applications, all the way up to much more complicated stuff like how do I do monitoring of containers, what do I do about getting configuration into my applications, and lots of best practices. There's CI/CD stuff in there as well. So there's a lot of stuff in there. The thing I've tried to do with this book is make it as kind of widely applicable as possible, because a lot of the existing Docker books are very good, but they're targeted at a specific background. Whereas Docker itself kind of spans development and operations and architecture. So I've tried not to have too many prerequisites with this book. And I would hope anyone from those backgrounds can pick up this book and get going with it. And the other thing is it's every single example, I've made sure that it works on Linux, Mac, Windows, and Raspberry Pi. So, whatever you're using, everything should just work. And hopefully that's kind of the goal for this.
So hopefully we'll have a new fresh-faced generation of Docker learners.
Yeah,
and
hopefully.
Creators. So we've managed to cover off, I think, literally everything. We've got application transformation, cloud native, and containerization. Is there anything else you'd like to add?
Is there anything I'd like to add? Well, I mean, I think the important thing with this is to realize that the speed that these things are moving at is, especially Kubernetes, like Kubernetes is accelerating towards light speed. And if you listen to how the vocal thinkers of Kubernetes, they're talking about a future where you don't have to care about the cluster and you'll just send your manifest somewhere and it will spin everything up. And I think that's great. And we will surely get there. But there's going to be a long period in between where people are managing their own clusters and spinning things up and having to know some of the internals. And I don't think that should be scary, because yes, you have to learn some of this stuff, and yes, there's an investment in getting there, but the payback for that investment is better than kind of anything I've seen in my career. So I've been doing this for 20 years, and containers and the ability to take your app, make it run in Docker, and then run it on any cloud, and it's the same everywhere, and then you run it on your laptop. Like if you need to reproduce a production problem, you can spin up the exact same stack right down to the operating system on your machine with a single command. That's incredibly powerful. We haven't been able to do that, and even though the future is going to take away some of the core components, and you won't need to worry about that stuff right now, it's okay to dig into that and to learn how those things work, because it's gonna just make your life so much easier.
Yeah, well, that's absolutely brilliant, and I think that winds us up for today. So, Elton, thank you so much. It's been ridiculously insightful.
Well, you're welcome. Thank you for having me. Yeah, I'll be glad to listen when it comes out.
Yeah, I'm excited to say, dear listener, that we have a special offer for you today. If you'd like to get your hands on a copy of Elton's book, Learn Docker in a Month of Lunches. I was about to say a bunch of lunches. That's just a whole lot less professional.
I refer to it as a bunch of munches.
Oh, that's brilliant. You can get it today. You can get your hands on, I think it's currently up to about 9 chapters. Mm-hmm. And you can get that through manning.com/books/learn-docker-in-a-month-of-lunches. If that happens to be a few too many hyphens for you, we've created a quick link for you to follow, which is expert.it/LDIAMOL. Learn Docker in a Month of Lunches, which I thought was very good. Hola diamol. Go there, you can use the discount code PODCLINS19, that's PODCLINS19, and you can get up to, I think it's a hefty 40% discount. And I think this works across all products and all formats forever. And you can find all those details, if you didn't want to listen to all the hyphens, in the show notes. Elton, thank you so much. It's been absolutely great. If anyone would like to reach out to you, would like to just have a chat about Docker containers, just talk to you in general, where can they get you?
Twitter is probably best, so I'm just at Elton Stoneman on Twitter. My LinkedIn is just Elton Stoneman. I have the advantage of an unusual name, so you can just search me and you'll probably find me.
That's brilliant. If anyone would like to reach out to me, you can get me on Twitter at CI_Stu. Alternatively, you can get us at Cloud Insiders. We're available on iTunes, Spotify, Acast, TuneIn, SoundCloud, Google Podcasts, wherever you pick up your podcasts. All our episodes can also be found on YouTube, and you can visit us at cloudinsiders.fm. If you'd like to reach out and talk to us or have any ideas for future episodes, you can get us at team@cloudinsiders.fm. Elton, thank you so very much.
Thank you very much. And I'll be glad to come back on in the future if you've got something else to talk about.
Oh yeah, we're always glad to have you back on. I mean, it's been absolutely fantastic. And to everyone at home, we will catch you next time.